Dear, dear students, good afternoon to all of you. Myself, Dr.S.Vimalnath, Assistant Professor from ECE Department, working for Erode Sengunthar Engineering College, located at Erode. Today, we are going to see about the lecture video on smart antenna. Some basics of smart antenna we are going to see today. This is the outline of my video. First of all, introduction to smart antenna. And second one, what is smart antenna? And third one, types of smart antenna systems. And fourth one, what are the goals of a smart antenna system? And next one, architecture of the smart antenna. And next one, benefits of switched beam antenna and adaptive array antenna system. These are the two different types of smart antenna. And next one, who can use the smart antenna? What are the applications of smart antenna? And next one, what are the advantages of smart antenna? And next, the conclusion part. This is the outline of today video. First of all, we will see about some intro of smart antenna. And the smart antenna was developed for military communication and intelligence gathering for the application of military communication and intelligence gathering. The smart antenna was developed. New opportunities were created for smart antenna in the year of 1990. Satellite broadcasting industry. The satellite broadcasting industry developed the smart antenna in the year of 1990. First of all, before entering into the topic, first of all, we should know about what is antenna. Antenna is a electrical device which converted electrical power into electromagnetic waves. Antenna is working as a medium. So a smart antenna consists of an antenna array that changes the array pattern in response to signal environment to improve the performance of a communication channel. That is called as smart antenna. What is smart antenna? Consists of an antenna array that changes the array pattern in response to signal environment to improve the performance of a communication channel. So smart antenna is not smart. It is the digital signal processing along with the antennas which makes the system to be smart. This is the smart antenna. A smart antenna system combines an antenna array with a digital signal processing capability to transmit and receive in an adaptive manner. So what is the difference between regular antenna and smart antenna? A regular antenna is working as a omnidirectional. It generates beam in all direction, having directional pattern in orthogonal plane and non-directional pattern in a given plane. That is the regular antenna. But smart antenna, the adaptive antenna utilize the adaptive digital signal processing based techniques and digital technology. This is the basic difference between the regular antenna as well as smart antenna. Next of all, we should see about co-channel interference. What is co-channel interference? It is a crosstalk from two different radio transmitters using some frequency. Using same frequency. So that is that will make a crosstalk interference. So next of all, co-channel interference arises in the cellular mobile network owing to the phenomenon at the frequency reuse. This is the co-channel interference. So avoid the co-channel interference, we should use the smart antennas in a application. So the functioning of smart antennas is still far from being well defined, and many concepts are subjective through studies. The technical aspects involve number of elements fed with the signal which are adaptively processed by space or space-time filtering. This is the functioning of smart antenna. What are the next function? The potential demands are put on the functioning at smart antennas. There are many functions. First of all, increase the number of subscribers, higher data transmit rate, and better spectral efficiency, extended range, and next one processing of multipath propagated signals, and very flexibility of channel transfer. This is the important function of the smart antenna. That's why we are using smart antennas. Uh, Coming to intro of smart antenna. Yeah, already I have told a smart antenna system combines multiple antenna elements with a signal processing capability to optimize the radiation or reception pattern automatically in response to the signal environment. The beam radio signal directly at a user to follow the user as a move. What is smart antenna? A smart antenna system combines a multiple antenna elements with a signal processing capability to optimize its radiation and the reception pattern automatically in the response to the signal environment. It's true, the antennas are not smart antenna system or smart. Generally co-located with their base station, smart antenna system combines an antenna array with a digital signal processing capability to transmit or receive in an adaptive manner or spatially sensitive manner. That is the function of smart antenna. What are the types of smart antenna? A smart antenna system are customarily categorized as either switched beam or adaptive array system. What is the switched beam array? A switched beam, a finite number of fixed or predefined patterns or combining strategy. That is called as switched beam antenna. The next one, adaptive array. It is an infinite number pattern that are adjusted in a real time. The switched beam is a finite number of predefined pattern, but adaptive array is a infinite number of predefined pattern. So this is the basic difference between the switched beam antenna and the adaptive array antenna. Next, we should know about the switched beam antenna. What is switched beam antenna? Where we are using the switched beam antenna. It forms the multiple fixed beams with the heightened sensitivity in particular direction. This antenna system to detect the signal strength choose from one of several predetermined or fixed beams and switched from one beam to another beam as the mobile moves throughout the sector. That is the examples of switched beam antenna. So the switched beam system combine the output of multiple antenna in a such a way as to form finely sectorized or directional beams with the more selectivity. This is the switched beam antenna. Next one, we should move on adaptive array antenna. What is meant by adaptive antenna? Antenna array. Adaptive antenna technology represent the most advanced smart antenna approach by using a variety of new signal processing algorithms. So it provides the optimal gain while simultaneously identifying or tracking and minimizing the interfering the signal. Whenever interfering the signal, it will collapse the entire communication. So it will be minimized by using this adaptive array antenna. This is the basic diagram for the switched beam array adaptive antenna and adaptive array antenna. The first one is indicating the switched beam antenna and next one is the adaptive antenna. This is the radiation pattern of switched beam as well as adaptive antenna. The user are transmitting the information to the interferer antenna. So next is the user 1 and the subscriber and the interferer 2. It's mentioned in the adaptive array. So the radiation pattern will be differed both of them. What are the goals of smart antenna system? The main purpose of a smart antenna system is to augment the signal quality of the radio based system through more focused transmission of radio signals while enhancing the capacity through increase the frequency reuse. That is the main purpose of, that is the main goal of smart antenna system. What are the features of a smart antenna system? The features of a smart antenna system are, first one is signal gain, and second one is the interference rejection, and third one is the power efficiency. These are all the main features of the smart antenna system. The one is signal gain and provide the interference rejection and provide the power efficiency. The next we will see the architecture of smart antenna system. The switched beam and adaptive array system enable a base station to customize the beams they generate for each remote user effectively by means of internal feedback control. So, listening to the cell for the uplink processing and speaking to the user for the downlink processing. It is a transmitting antenna to the receiving antenna. It is the uplink processing, and the receiving antenna to the transmitting antenna is the downlink processing. That is used for listening to the cell and speaking to the user. This is the basic architecture of smart antenna. First of all, we should know, before entering into the architecture, we should know about some basics of uh, antenna system. Nowadays, we are using the 5G network, multiple input, multiple output antenna system. That is a multiple input, multiple output. There is classified into four classification. First one is single input, single output, single input, multiple output, multiple input, single output, multiple input, multiple output. In a 5G network, we are using multiple input, multiple output. That smart antenna we are using in a 5G network. In a recent technology, we are using this multiple input, multiple output smart antenna. This is the basic architecture of smart antenna. Here, there are many input we are giving. Antenna 1, antenna 2, likewise antenna n number of antenna we are using. The signal which is classified into down converter, and the down converter transmitting the information to the analog to digital conversion. Analog to digital conversion convert the analog signal whenever receiving the digital converter input uh, to the analog to digital conversion. The analog to digital conversion converting the analog signal into digital output by using the three important process. One is sampling and quantization and encoding. What is meant by sampling? Sampling is nothing but the conversion of continuous time signal into discrete time signal. That is called as sampling. The sampling theorem is nothing but the sampling frequency greater than or equal to 2 FM. Whenever satisfying this condition, the analog signal converted into discrete time signal. Otherwise, aliasing effect will be affected. I mean, the signal will be overlapped. Uh, if the sampling frequency exactly equal to 2 FM means that is the Nyquist rate. That is called as Nyquist rate. So Fs greater than or equal to 2 FM is the sampling theorem. So we have to satisfy the condition for converting analog continuous time signal into discrete time signal. Then the discrete time signal will be digitized by using the quantization. The quantization output will be given to the encoder. All the digitized signal will be converted into coded format by using the encoder. The encoder output will be purely digital, then will be given to the complex weights, the W1, W2, and WN. So all the weighted digital signal can be combined with the help of summation with the help of the digital signal processor. In this processor, the adaptive algorithm we are using in the conversion of digital signal, it can be it can be processed to the demodulator. The demodulator which is used for produce the again convert into the analog signal to the receiver end. So this is the basic architecture of smart antenna. So next we will see the benefits of switched beam and adaptive array system. What are the benefits behind the switched beam antenna and adaptive array antenna system? First one is integration. Second one is the range or coverage. And next one is the interference suppression. So what is meant by integration? Integration will be uh, splitting the signal from one form of signal into another form of signal. So range or coverage, and the coverage area is very important factor. So the increase the coverage area with the help of not antenna. Next, interference suppression. Some noise or some carrier signal will be added to the original signal. Some noise will be affected with the help of modulation. So it can be avoided by using this switched beam and adaptive array system. And where we are using smart antenna system, A smart antenna technology can significantly improve wireless system performance and economics for a range of potential users. The potential users increase the range of the signal. It can be used in a smart antenna system. It enables operators of PCS or cellular and wireless local loop network to realize significant increases in signal quality and capacity and coverage. These are the applications of smart antenna system. What are the advantages behind the smart antenna system? The smart antennas can help the system meet these requirements in the following manner. First of all, both phased and adaptive array provide increase the power by providing the higher gain. So increase the gain as well as increase the power for the desired signal with the help of smart antennas. So in terms of interference suppression, phased array reduce the probability of interference with the narrower beam, and adaptive arrays adjust the beam pattern to suppress the interference. What are the uses of smart antenna? Phased arrays are mainly being studied for point-to-point wireless system. Example, for wireless local loop. Adaptive array are being considered on cellular terminal where local scattering causes wide angular spread. So spreading the angular in a wide manner with the help of adaptive array. So in the TDMA system, ANSI 136 adaptive antenna algorithm have been widely deployed. These are the uses of smart antenna. Let me conclude. The use of smart antenna is not purely a radio transmission issue. It also influences the network services such as handover and connection setup. A smart antenna is a digital wireless communication antenna system that takes advantage of the diversity effect at the source as well as the destination or both. To provide the diversity effect in the transmitter and receiver, we are using a smart antenna digital wireless communication system. In adaptive array antenna has become a core component in future generation mobile networks. Adaptive array allows the antenna to steer the beam to any direction of interest while simultaneously nulling the interfering the signals. This antenna can track and locate the signal. If we see some MCQ questions related to smart antenna, the first one is which of the following statement is false regarding the smart antenna for 802.11 applications. The question is which of the following statement is false regarding the smart antenna for 802.11 applications. First one is coverage area is increased. The option B is signal paths are reduced. Option C is probability of collision is increased. And option D is interference is reduced. Which one is the right answer? The right answer is option C. Probability of collision is increased. Why? Because the smart antenna allows improve the signal to noise ratio. So coverage area is also increased. The signal paths are reduced. So the multi-path reduction, the transmitted RF energy is confined to a desired direction. So interference is reduced. Probably collision is reduced and network capacity is increased. So probability of collision is increased. So which of the following is not advantages of smart antenna? The option A is range is increased. Option B is secure transmission. Option C, design of transmitting or receiver is simple. Option D, probability of collision is reduced. Which one is the right answer? Option C is the right answer. So design of transmitter receiver is simple. Why? The design of transmitter receiver for a smart antenna is quite complex than a traditional base station transmitter or receiver. The secure transmission, increase in range, reduction in probability of collision is benefits of a smart antenna. So the option C is the right answer. The next question, which of the following is used to distinguish the selected signal and the multipath signal in smart antenna architecture? Option A is DSP procedure, digital signal processing procedure. Option B, switched beam array. Option C, range gate. Option D, delay canceller. Which one is the right answer? Option A, digital signal processing procedure is the right answer. Why? Because adaptive array systems change the sign pattern with respective to radio frequency settings. So the DSP procedure is used to differentiate the selected signal from the multipath signal. The switched beam is used for forming multi-rays in a specific order. So the range gate and delay line canceller find the application in MTI radars to get the accurate target information. So the option A, DSP procedure is the right answer. The next question, which of the following is mostly used to generate multiple fixed beams by augmentation in specific order? Options are option A, switched beam array. Option B, range gates. Option C, conical scanning. Option D, FMCW radar. Which one is the right answer? Option A, switched beam array is the right answer. Why? Because the switch beam is used for forming multi-rays in a specific order. The range gate and delay line canceller find the application in a MTI radar to get the accurate target information. In conical scanning, continuous scanning is performed by a beam antenna. So the option A, switched beam array is the right answer. The next question, in which of the following type of smart antenna the performance of the multi-channel fading is limited? Options are option A, diversity system. Option B, omnidirectional system. Option C, sectored system. Option D, directional system. Which one is the right answer? Option A, diversity system is the right answer. In diversity system, multipath fading, co-channel interference, delay spread impairments are greatly reduced in the smart antennas. The directional system use the sectored antennas reference to provide the energy to intended direction. So the diversity system is the right answer. The next question, which of the following is not the benefit of smart antenna? The options are option A, it increases the SIR. Option B, it decreases the SIR. Option C, it increases the SNR. Option D, probability of collision is reduced. Which one is the right answer? Option B is the right answer. It decreases the signal to interference. So that is the right answer. Why? Because the probability of collision is reduced, so the interference is also reduced in smart antenna. Thus, the signal to interference increases in this, the signal to noise ratio is also high. As the multipath fading is also reduced the diversity type of system. It must be signal to noise ratio will be decreased. So option B is the right answer. The next question, in smart antenna, signal to interference ratio is low. It is true or false? Which one is the right answer? Option B is the right answer. Because the probability of collision is reduced, so the interference is also reduced in a smart antenna. Thus, the signal to interference increases in this by increasing the signal strength and reducing the interference. So, signal to interference is increased. So, option B, false is the right answer. It is a false statement. The next question, which of the following suffers the co-channel interference most? Options are option A, smart antennas. Option B, sectored antennas. Option C, omnidirectional antenna. Option D, both smart antenna and omnidirectional. Which one is the right answer? Option C, omnidirectional is the right answer. Why? Because the omnidirectional suffers more co-channel interference compared to the sectored and smart antenna. Probability of collision is reduced, so the interference is also reduced in a smart antenna. Thus, the signal to interference will be increased. So, option C, omnidirectional is the right answer. Which of the following suffers the co-channel interference most? So, the omnidirectional is the right answer. Next question. The smart antenna can be used for location-specific service. It is a true or false statement. Which one is the right answer? Option A, it is a true statement. Why? Because the spatial detection nature of the smart antenna, which enables to locate the humans in emergencies. It is used for location specific service. So it is the right statement. The next question, which of the following is benefit of smart antenna? The options are option A, it is easy to tap the connection by the intruder apart from the user. Option B, co-channel interference is less compared to the omnidirectional. Option C, design of transmitter receiver is complex. Option D, it cannot be used for location specific services. Which one is the right answer? Option B, the co-channel interference is less compared to the omnidirectional. That is the right answer. So why? Because the spatial detection nature of the smart antenna, which enables for location specific services. The probability of collision is reduced, so the interference is also reduced in a smart antenna. Thus, the signal to interference increases in this. The smart antenna provides the security, so it is difficult to intruder to get the user connection. So option B, co-channel interference is the less compared to the omnidirectional. These are all the reference. Okay, thank you. Next video we will see the other special antennas. Okay, thank you to all of you. Okay, thank you to all of you. In this video, I have explained what is the smart antenna, what is meant by smart antenna, what are the classification of smart antenna, what are the applications and advantages of the smart antenna, what is meant by smart adaptive array antenna and smart beam antenna. These are the two different classification of antenna. What is the architecture of smart beam antenna or smart antenna? I hope you all next video. I hope you all you are very clear about smart antenna. Next video we will discuss about the some smart some special antennas. Okay, thank you.